आइए समझते हैं. Let's understand. Welcome to this explainer. Ever wonder how you can actually really talk to machines? Well, that's our ultimate goal today. Whether you're a student, a working professional, or literally just someone who wants to learn programming for the very first time, you are in the exact right place. We're going to completely demystify coding, taking you from absolute zero all the way to writing your very first real piece of code. Let's get into it.
Think about this for a second. How do you actually talk to a computer? I mean, to talk to another human being, we need a shared language, right? If you're speaking English or Hindi, the person you're talking to obviously needs to understand English or Hindi too. Otherwise, you're just, communicating in wild gestures. The exact same logic applies to machines. To get a computer to analyze data or control a device, you gotta speak its language. Python is simply one of those languages. It's a translator between your human instructions and the machine. So here is our roadmap of the building blocks we'll cover today. First, an introduction to Python. Second, writing your first code. Third, we'll look at how Python executes code. Fourth, understanding variables. And finally, exploring data types.
Okay, let's dive into this with Section 1. Introduction to Python. It's a high-level, incredibly human-readable language created around 1990 by a guy named Guido van Rossum. And man, making it human-readable has paid off massively. According to survey data from Statista, Python is literally the #1 most popular programming language in the entire world right now. It completely beats out other massive heavyweights like Java, JavaScript, and C#. But why exactly is everyone choosing Python? Well, there are a few absolutely crucial reasons. First and foremost, it is incredibly beginner-friendly. If you've never coded a day in your life, seriously, do not panic. It's also completely free, open source, and has this massive community backing it up. But the real magic? That lies in its libraries. Libraries are basically just pre-written chunks of code that do the heavy lifting for you. Like say you want to work with data tables, kind of like Excel. You just pull in the pandas library, and boom, you're set. Want to work with medical x-rays? Yep, there's a library for that too. This power combined with simplicity really opens the doors to huge career opportunities in web development, AI, and data science. Moving on to Section 2, writing your first code. This is where we get practical. I mentioned a second ago that Python is extremely beginner-friendly, and when you see the contrast, it's honestly pretty stark. If you want to instruct the computer to just pop the words "Hello World" onto your screen using Python, you use a built-in function called print. You just type print, open parentheses, quote, "Hello World," close quote, one single line. That's the whole shebang. If you were doing this in, say, C# or Java, you'd have to write 3 or 4 lines of code, stress over rigid brackets, set up complex classes, all just to do the exact same thing. Even counting numbers from 1 to 10 takes just a fraction of the code in Python compared to those clunky alternatives. It genuinely reads almost like plain English. Section 3, how Python executes code. Now, what's really interesting about this slide is getting to peel back the curtain and see what actually happens when you hit that run button. Under the hood, it follows a really clear 5-step flow. First up, you have your source code. That's just the human instruction you just typed out. Second, the interpreter jumps in and performs what's called lexical analysis. Basically, it breaks your code down into smaller bite-sized parts called tokens. And it checks your syntax. It's making sure you follow the grammar rules, like, hey, did you forget a parentheses? Third, if your syntax looks good, it translates your code into bytecode. This is a simpler set of instructions that the machine can actually digest. Fourth, the Python virtual machine, or PVM, steps up and executes that bytecode line by line. And finally, step 5, boom, you get your output. A really absolutely crucial part of that whole process is the interpreter. You see, programming languages usually use either an interpreter or a compiler. Python uses an interpreter, meaning it translates and executes your code line by line. On the flip side, languages like C++ use a compiler, which tries to translate the entire program all at once before it runs anything. Now, because Python goes line by line, sure, it's slightly slower, but here is the massive benefit. Debugging is just vastly easier. If there's an error or a bug, Python stops right at the exact line where the mess-up happened. That makes it incredibly easy for a beginner to spot and fix their mistakes. Which brings us to Section 4, understanding variables. So the crucial point is, we need to learn the basic grammar of Python. The best way to think about a variable is simply as a container. Imagine a little labeled box where you can safely store different types of data. You assign a value to this container using the equals operator. For example, if you type a equals 1, a is your variable container, and 1 is the value safely tucked away inside. Why do we bother doing this?
Well, imagine you have this huge, complex sentence that you need to use like 10 different times in your code. Instead of copying and pasting that monster of a sentence over and over, you just store it in a variable. Then you just type the short variable name. And the best part, if you ever need to change the sentence later, you only change it once inside the container, and it instantly updates everywhere else in your code. It's a real game changer. But Python is very strict about how you name these containers. There are uncompromising rules you have to follow. Rule 1. Your variable name absolutely must start with a letter or an underscore. Rule 2. It can only contain letters, numbers, and underscores. If you try to sneak in a special symbol, like a $sign, your code will instantly break and throw an error. Rule 3. They are highly case sensitive. So a variable named sales with a capital S is an entirely different box than sales with a lowercase s. And finally, you cannot use reserved Python words. Words like for already have a very specific job in Python, so you can't go using them as your own variable names. Because we use variables constantly, the industry has actually developed standard ways to name them, just so other humans can easily read what you wrote. For instance, Pascal case capitalizes the first letter of every single word. Camel case leaves the very first word lowercase but capitalizes the rest. Flat case is all lowercase, which honestly can be pretty hard to read. And then there's snake case, which is super popular in Python. It uses all lowercase but separates words with underscores like my_name. Picking one of these styles and sticking to it makes your code look super clean and professional.
Section 5, Exploring Data Types. Let's move to and see how this builds on everything we've talked about to stack our final block of knowledge.
Quick question, does 1 + 1 = 11? I mean, in math, no way. But in Python, it absolutely can. And this perfectly proves exactly why data types matter so much. See, if you give Python the integer number 1 and add another integer number 1, it will output 2, normal math. But if you put those ones inside quotation marks, Python no longer sees them as math numbers. It sees them as text words. So instead of adding them, it just glues the two text characters together, putting a 1 right next to another 1, giving you an output of 11. Crazy, right? That is exactly why we need to classify our data. A data type basically specifies the exact kind of value a variable is holding, so Python knows what operations it's actually allowed to perform. Like we just saw, you can't do regular math on text. Now, if you are ever confused about what exactly is sitting inside your variable container, Python has this really handy built-in detective function called type. You literally just pop your variable inside the type function, and Python will print out exactly what category of data you're dealing with. Here's a quick rundown of those core data types. First off, numeric data. This includes whole numbers, which we call integers, numbers with decimals, called floats, and even complex numbers for advanced math. Next up is sequence data. If you put text inside quotes, that's a string. If you want to group multiple items together, you use square brackets to make a list, or parentheses to make what's called a tuple. Finally, there's the dictionary type, and you write that with curly brackets. Just like a real-world dictionary, it maps a specific keyword directly to its value. And honestly, just like that, you've learned the fundamental building blocks of programming. You know why Python is such a powerhouse, you know how it interprets your commands line by line, and you understand the strict rules behind variables and data types. You are no longer just a human interacting with a screen, you're becoming a translator. So, I want to leave you with this final provocative thought. Now that you actually know how to speak the machine's language, what will you build first? Get out there, start your coding journey today, and I will catch you in the next explainer.